Hello everyone, my name is Jevin George and today I'm going to be explaining how to solve an assignment problem in operational research. Assignment problem refers to a special class of linear programming problems that involve determining the most efficient assignment of people to projects, salespeople to territories, and contacts to binders and so on. It is often used to minimize total cost or time of performing tasks. One important characteristic of assignment problem is that only one job or worker is assigned to one machine or project. Given here is an example of how to solve an assignment problem. The first step to solve an assignment problem is to check if the number of rows are equal to the number of columns. If they are not equal, we have to add a dummy row or a dummy column. As seen in the example given, the number of rows are 5 and number of columns are 5, hence they are equal. And let's move to the next step, that is row minimizing. In row minimizing, we got to take the smallest value of each row and minus it from each unit in the cell. For example, in the first row, the smallest value is 9, and then we need to later minus it with each and every value in that row. Then comes column minimizing. After we minus all the values from row minimizing, we got to check again in the column wise and find the minimum values and minus it from each element of the cell. As we can see here, in the first column, the smallest value is 0, second column is 0, third is also 0, and the fourth column we can see the minimum value is 2. So we got to minus 2 from each and every cell in that same column. And even the last one, we have the minimum value as 10, we got to minus that from each cell. Then comes row matching and column matching. After row minimization and column minimization, the final table we need to start this process called as row matching and column matching. First comes row matching. We need to check the first row. If it has more than one zero, we got to exclude that, omit that row and move on to the next row. Since we have 3 zeros in the first row, we are excluding that and moving on to the next row. In the next row, since we have only 1 0, we got to vertically strike out that row and omit that row which has been striken out. Then we move on to the third row, which also has 1 0, and we vertically strike out that row. Then we move on to the third row, where there is also only 1 0, and then which later gets striken out. And when we move on to the fifth and final row, there is no zeros, so row matching has been complete. Then we move to column matching, where we check column wise if there is one or more zeros. The first column has been striken out, second also has been striken out, third also has been striken out. When we come to the fourth column, we can observe that there is only 1 0, so we cut the row horizontally. And then when we come to the final column, there are no zeros, so row matching and column matching is complete. Once we check the number of squared zeros and number of rows are equal or not. In this diagram, we can see that the number of squared zeros are equal to 4 and the number of rows are equal to 5, which makes them not equal. So we got to take the smallest value in the non-striken out digits, which is 2, and add it to all the intersecting points where there are two crosses. So in this we can see 0, 13 and 49 are the intersection points. We need to add the smallest value, that is 2, to those points, making 0 into 2, 13 into 15 and 49 into 51. And the points that are just striken out, we should leave those values the same, and the points that are not striken out need to be minus with the smallest value, that is 5 will become 3, 10 will become 8, 7 will become 5, again 7 will become 5, 20 will become 18, 2 will become 0, 9 will become 7, and 4 will become 2. After making the new table, we got to conduct row matching and column matching again. So as you can see, when we check the first row, there are 2 zeros, hence it is omitted. When we move to the second row, there is 1 0 in the first column, so the first column gets striken out. When we move to the third row, there is 0 in the second column, hence the second column also gets striken out. When we move to the third row, since there are two zeros, that row is omitted, and when we move to the final row, there is no zeros, hence row matching has been complete. Then we move to column matching, where the first column is checked. For first column, since it has been striken out, we are omitting that column. Even the second column has been stricken out, so we are omitting that column. When we move to the third column, we can see there is 1 0. Hence, we are striking that row horizontally. And then when we move to the fourth column, we can see that there is 1 0, and we are striking out that row horizontally. Again, we got to check in the final column there are no zeros, so we are not striking out anything. Once again, we need to check if the number of squared zeros is equal to number of rows, which is still not true, as the number of squared zeros is 4 and number of rows is equal to 5. So we need to take the smallest value from the cell again, that is 2, which is not stricken out, and add it to all intersection points, and minus it from the non-stricken out values, and keep the striken out values the same. After completing that, we get a new table. In this new table, we got to conduct row matching and column matching once more. In the first row, we can observe that there are 2 zeros, hence it is omitted. Then we move to the second row where there is 1 0, making the first column get striken out. When we move to the third row, there is 1 more 0, making the second column striken out. When we move to the fourth row, we see that there is 2 zeros, hence we are omitting that row. And when we move to the final row, we see that there is only 1 0, making the final column striken out, hence ending row matching. Now we got to move to column matching. Since the first 2 rows are striken out, we got to start from the third row where there is only 1 0, making that row where the 0 is striken out. When we move to the fourth row, there is 1 0, we got to strike out the first row. And then when we move to the final row, since it's already striken out from row matching, we can ignore that row. Now the number of striken out columns are equal to 5, number of striken out zeros are equal to 5, making it equal to number of rows. Hence we need to stop row matching and column matching. Okay, now comes to the final answer, that is total processing time. Create a table with 3 rows which consist of jobs, persons and hours. The values in the R column are taken from the squared zeros from the original table. We add those values in the R's, and then the total value is called the total processing time. That's all for assignment problem. Thank you.